If you've ever used ChatGPT or even just a modern search engine, you've seen what a transformer can do. It's the AI architecture that literally changed everything. And it all started with a totally revolutionary way for machines to understand language.
This really gets to the heart of what a large language model is trying to do. It's not just about memorizing and repeating information. It's about finding the deep, underlying patterns in all of it, seeing connections at a scale that's hard for us to even comprehend. And what comes out the other side? Well, it really starts to look like thought.
Okay, so how does a machine even learn to talk? You might be surprised, but this whole AI revolution is built on a really simple idea. Just predicting the next word in a sentence.
You and I, we know the word here is probably west. But a language model, it doesn't know that from looking at the sky. It learns it by crunching billions of sentences to calculate the most statistically likely answer. That's its entire universe. Pure probability.
For decades, though, this whole prediction thing was stuck. It was held back by a fundamental problem. AI models simply had terrible memories.
The old models, things called recurrent neural networks, or RNNs, they process text sequentially, one word at a time. And the problem with that, it's like reading a massive novel, but by the time you get to the last chapter, you've completely forgotten who the main character was from the beginning.
And this created what engineers called an information bottleneck. Imagine trying to funnel an entire library of information through a tiny little straw. The model's memory was just too fixed, too small. It couldn't hold on to enough data. Because of that, understanding long paragraphs or, the subtle nuances of language, basically impossible.
And then, 2017, a research paper drops from Google and it completely changes the game. It proposed a totally new, almost radical way for AI to process information.
This paper introduced what we now call the transformer architecture. And it was a seismic shift, a complete break from that slow, one-word-at-a-time way of doing things.
The title of the paper was so bold, so confident. Attention is all you need. And that title revealed its core secret. They asked, what if, instead of reading word by word, a model could look at the entire sentence all at once? This ability to weigh how every single word relates to every other word, that's what they called attention.
Okay, so this is where things get really interesting. How on earth does a machine pay attention to a whole sentence at the same time without just getting completely lost in the noise? Well, the solution is just brilliant. It's this elegant, three-step process that gives the machine an incredibly rich understanding of context, something that was, totally out of reach before. So, step 1, give words meaning. Words get turned into numerical codes called embeddings. But these are not random numbers. No, they're like coordinates that place words on a giant map of meaning. This is what lets the model do this kind of word algebra. It can actually see, mathematically, that the relationship between king and man is the same as the one between queen and woman. It's incredible. Okay, but wait. If the model sees all the words at once, how does it know their order? I mean, the dog bit the man is very different from the man bit the dog, right? Well, that's solved with positional encoding. It's like adding a unique mathematical rhythm or a beat to each word's code. It gives the model that crucial sense of sequence and grammar. And now for the final and maybe most important step. We've got the words, we've got their order, so how does the model figure out which ones are most relevant to understanding any other word in that sentence? This is where the magic of self-attention comes in.
The best way to wrap your head around self-attention is to think of it like a tiny search engine that runs inside the sentence itself. And for every single word, the model generates 3 little pieces of information: a query, a key, and a value.
So here's how that little search engine works. The query? That's the word the model is focused on right now. It's your search term. The model then takes that query and compares it to the key of every other word in the sentence. You can think of the keys like the tags or titles on a video. Based on how well the query and keys match up, it decides how much of the value to pull in. And the value, that's the actual meaning, the real substance of each of those other words. It's a super efficient system for finding relevance.
And what you get from all that is a set of attention scores. So, in a sentence like, I made a sweet Indian rice dish, if the model wants to understand the word dish,
It runs this process and boom, it learns to pay a ton of attention to sweet, Indian, and rice, and to pretty much ignore words like I or a. It just knows what's important.
Now here's the truly mind-bending part. This super complex calculation, it happens for every single word, all at the exact same time. It's massively parallel. In fact, it's not just one search. The model runs multiple attention searches at once. This is called multi-head attention. And that lets it find all sorts of different relationships in the data simultaneously.
So this architecture, this idea of processing everything in parallel and using attention to figure out what matters, this is what finally broke AI free from the chains of sequential memory. It just unleashed this wave of unbelievable new capabilities.
This single idea is the foundation for pretty much the entire AI boom we're seeing right now. It's the engine inside the chatbot on your phone, the code generator helping developers build software, and even the powerful research tools accelerating scientific discovery. But the scale here, it is just immense. These models are trained on what feels like the entire internet using these enormous supercomputers. And the cost? We're hearing reports that training just one of these top-tier models like a GPT-4 can cost well over $100 million.
And that is a really important thing to remember. For all their amazing abilities, these models don't think or understand the way a person does. What we're really looking at here is a monumental achievement in mathematics and engineering, fueled by colossal amounts of computation. It is not the birth of a conscious machine. The transformer isn't just another piece of technology. It has fundamentally redefined what's possible, and it forces us to ask some really profound questions about where the line between calculation and understanding truly lies. The shock waves from that one paper back in 2017, well, we're still feeling them today, and they are shaping the future we are all building right now.